Welcome to myprojectbazaar.com. Here we discuss about reduction of transient and steady state speed pulsation in permanent magnet synchronous motor using space vector pulse width modulation control. It is well known that multi-level inverters have been receiving more and more attention for high voltage and high power applications. Number of topologies and modulation strategies have been investigated for utility and drive applications in recent years. Multi-level inverters are suitable in high voltage and high power applications due to their ability to synthesize waveform with better harmonic spectrum and attain higher voltages within limited maximum device rate. The maximum better known topology are the H-bridge cascaded inverter, the flying capacitor inverter, and the diode clamped inverter. The most attractive features of multi-level inverters are as follows. They can generate output voltages with extremely low distortion and dV by dt. They draw input current with very low distortion. They generate smaller common mode voltage, thus reducing the stress of the mount bearing. In addition, we use sophisticated modulation methods that CM voltage can be eliminated. They can operate with a low switching frequency. Based on the analysis of diode clamping, three-level inverter topology, and the review of space vector PWM method, this paper proposes a novel space vector PWM modulation strategy to reduce switching. Here we using permanent magnet synchronous motor to act as a load which maintain the target level by using space vector PWM modulation technique. The concept of space vector is derived from the rotational field as AC machine, which is used for modulating the inverter output voltage. In this modulation technique, the three-phase quantities can be transformed to their equivalent two-phase quantity either in synchronously rotating frame or stationary frame. For this two-phase component, the reference voltage magnitude can be found and used for modulating the inverter output. The process of obtaining the rotation space vector is explained in phasor representation of our proposed SPWM modulation technique. Space vector PWM is a special switching sequence used in the three-phase power inverter. It generates a low harmonic distortion in the output voltages and currents applied to each plane of an AC motor and thus provide efficient use of supply voltage. In three-phase, three-level inverter, when the rotating voltage vectors fall into one certain sector, adjacent voltage vectors are selected to synthesize the desired rotation voltage vector based on the vector synthesis principle, resulting in three-phase PWM waveform. Now I am going to explain flow diagram of our project. In the first stage, we give the DC source as an input in the internal circuit, and this DC voltage was fed to the 6-leg pair switches to generate the inverter's output. The internal connections of each and every IGBT switches was controlled by using the feedback signal by using SPWM signals modulations of feedback signal. The feedback signal was given from the load side, and this feedback signal was fed to the coupling circuit. The coupling circuit will generate up to three-phase loading output. The feedback signal was fed to the SPWM to generate the switching controllers to control overall switches for 6 per switching legs. In this, the controller switches will generate the pulses which are to activate the switchings of total inverter circuits. At the load side, we can provide a three-phase load supply or an DC to inverter output, that is the three motor or act as a load. The supply gives the DC input and the controlling was provided by using SVPWM. The space vector PWM vessels will generate for each and every pulses. This will be made to control the 6-leg switches. According to the 6-leg switches, we extract the switching effect which will provide high frequency ranges and output will generate pulsed three-phase supply, and this pulsed three-phase supplies will reduce the harmonics to by using filtering. This filters finally provides the three-phase pure sine wave result from the extracted from inverter circuit, and finally this inverter output was fed to any analog load or any other motors. Now I am going to describe the running procedure of our project. In the first stage, we implement the circuit designs of 6-leg based inverter circuits. Then from the inverter circuits, we separated the phase A, phase B and phase C with the three-phase outputs and fed to the load side. This will generate the feedback signal and gives to SPVWM, that is the space vector PWM modulation designs to generate the controlling pulses for each and every switching devices in the inverter circuit. According to the feedback signal from the load side error, this will generate the modulator signals from SVPWM and this pulses for each gates for switching effect in the inverter circuits. From the scope, we can view the signal output of internal structure, displays the waveform structures of the stage. At the output end, we provide a scope to display the AC output, and finally, after running full, this will display an space vector, phasor figure at the final result. We can put any load as a three-phase, either DC load based motors or any other three-phase resistive load or capacitive or inductor load. The filtering circuit we filters the inverter output, which reduces the harmonics which are present in the inverter output, and finally we extract perfect three-phase signal at the load side. Thus we generate the error-free three-phase output to control the output load motor by using space vector PWM modulation technique. Thank you.